Hi there, this is David from DTU, the Technical University of Denmark. Welcome to this session. In this session, I'm going to talk about cumulative incidence. In epidemiology, we are very interested in determining how quickly a disease is appearing in a population, how many cases we have in a certain period of time. So with cumulative incidence, we can assess how quickly or how many cases we are getting in a certain period of time, which is very important when we want to plan health strategies or when we are dealing with an outbreaks. So in this, this session is part of the data management for epidemiological analysis module. So what are the learning objectives of this session? So after this lecture, you should be able to estimate the cumulative incidence. And you will be able to remember which were the steps to calculate the cumulative incidence, which is a very simple formula. And of course, you can also interpret what is the meaning of the outputs of the cumulative incidence. What is the meaning and how can we use it? So what is the plan? The plan in this session is that we will look at what is cumulative incidence, and we'll look at when can we use the cumulative incidence and how to estimate the cumulative incidence, the formula to calculate it, and we will look at some properties of cumulative incidence. So I hope you can enjoy this lecture. So the cumulative incidence is a proportion of disease-free population that becomes injured or diseased during a specific period of time. A useful way to think about cumulative incidence is the probability of developing disease or any other situation can be death in a stated period of time. Let me show you an illustration of the cumulative incidence. So we have a population at risk. A population at risk is important that is disease-free. We follow this population at risk for some time. We decide the time, it can be a week, a month, a year, or more, and then we count the number of cases we developed during the study period. So for example, imagine we have 2,000 cows, and these 2,000 cows are free from, let's say, mastitis. And we follow these 2,000 cows for 12 months. And we count the number of cases of mastitis during these 12 months. And that is how you end up with information that will help you to calculate the cumulative incidence. So it's important that the population at the start of the study is disease-free, at least for the disease that you are looking for. So when we get our data, we are ready to calculate the cumulative incidence. So how we calculate the cumulative incidence is very simple. It's a proportion, and it's a proportion of new cases arising during a certain period of time divided by the total population at risk. So by looking at this formula, we can see that the parameter A belongs to the number of new cases becoming infected during a period of time, whereas the parameter N represents the population at risk. Let's make a quick example. Let's say we have 500 cows, and we follow these 500 cows over a period of a week, and we count the number of lame cows during that week. And within that week, we obtain 10 lame cows. So with this information, we can calculate the cumulative incidence. So if we replace the information, we will get that 10 cases divided by 500 is going to give us 0.02. This means that it's a 2% lame cows in a week. In other words, two out of 100 cows will be lame in a week time. The observation period can be longer than a week. Let's say, for instance, in the next table, that we follow these 500 cows for more than 1 week. And in this table, we are showing the cumulative incidence for the following weeks. So our initial population at risk is 500. And in the first column, we have the week. And then in the second, we have the number of cases that are becoming lame during that population. And then on the third column, we are accumulating the cases through the time. So in week 1, we have 10 cases, and week 2, we have 15 cases. Plus the 10 cases we had is 25 cases during the 2 weeks' time. So if we calculate the cumulative incidence for the first week, it's going to be 0.02. Whereas for the second week, we have 25 cows out of 500 is going to be 0.05, and so on. So this study goes for another more weeks, and at the end of the study, we ended up with 370 cows out of 500, which became lame. So this is equal to the cumulative incidence of 0.74. In the final week, we had only 2 new cases. However, the accumulation was 370. So, for instance, for the 4-week, we have that there were 105 cows, and in that period, the cumulative incidence is equal to 0.21. The cumulative incidence can also be plotted, and we can see the same information, but in a graph. In a graph, and shows how quickly the cases are arising. We can follow the slope and see whether this is a very steep slope, and this will help us to determine whether we have also an outbreak when the cases are arising very quickly. So in the y-axis, we have the total cumulative incidence, and here we have the points which represent the cases per week. I just mentioned that cumulative incidence can help us to determine whether we have an outbreak. So cumulative incidence has also this name of attack rate, because it is it's a way to determine how quickly cases are arising. And I have an example about this in the following slide. Imagine we get the incidence of 2 scenarios. These 2 scenarios are presented here. Let's say that this is the incidence in a village. The cases are in village A in the left plot, and the cases in the village B in the plot in the right-hand side. So the step of the line is quite similar. However, if we look at the y-axis in the second plot, we can see that the cumulative incidence, it goes over 0.2, which is much lower compared to the cumulative incidence of plot A, or the plot on the left, which goes over the 0.7. So it's important to look carefully at the cumulative incidence, even that the line shows a very steep increase. It's important to consider the y-axis. So this might be a normal incidence of lameness in the cows, and this one might be an outbreak situation where we have to do something because of the cases are arising quite quickly. So we have the cumulative table of the second village or the second farm, where we have also this 500 cows at risk. And if we look at the final study period, we have only 0.27, which was much lower compared to the previous village. So it's important to have also this information in a table. So what is important when we look at cumulative risk is the way we report this when we talk to the public or to other colleagues. Because cumulative incidence is a proportion, and this is an advantage because it's somehow easy to interpret and to understand. So let me show you just an example of this. We have just seen the cumulative incidence in week 1, which was 0.2, and cumulative incidence in week 2 was 0.5. So if we multiply this by 100, so we have that we can report that there was 2% in a week time, 2% new cases in a week time, 2 out of 100 in a week time. And for the second week, we can say that we have 5 cases out of 100 in 2 weeks' time. It's important to mention always the time. Very often is that the time is missed when you see that in the headlines, and it is not very useful when you don't have the time included when you do cumulative incidence analysis. So in this video, we have seen the importance of cumulative incidence. We know the steps to calculate the cumulative incidence. It's a very simple formula, and it's a proportion, so we multiply the output by 100, and it gives us a fair figure which is quite easy to understand. And the cumulative incidence is useful for outbreaks investigations. So you know how to interpret the cumulative incidence by looking at graphs or making tables. So it's time to do some quizzes and exercises. In that way, you will understand the concepts very well of cumulative incidence.